am going to put up this summary of the rules. Okay. Now, if you look at here, this is a summary of all the vocabulary that we went through when we were doing algebraic expressions. Okay, it's all right, Ilham. It's good to see that you are back. Welcome back. I hope all your exams are going well. Okay, now let's look. The first thing we spoke about is coefficients. And those are my numbers in front of the variables. So in this case, 3 and 5 are coefficients. But I cannot say 9 is a coefficient because it does not have a variable next to it. So negative 9, it does not qualify as a coefficient. But instead, a number that doesn't have a variable next to it, that we call a constant. And that is because it does not change. Negative 9 will not change its value. It will remain negative 9. Okay. That's why we call it a constant, because it remains constant. Okay. Next, we're going to speak about our variables, which I have been mentioning the whole time now. Now, if I say something varies, that means that it changes. So that means X and Y do not have definite values, and it all depends on the expression or the equation or the question or whatever. Okay, so variables just means it does not have a set value, because for one question, X might be 2, but for the next one, if we solve it, X might be 10. Okay, so it varies, it depends. All right, these are also placeholders for actual numbers. So since we don't know what these numbers are, we just put an X and a Y. Then we spoke about terms, full-on terms. And our terms in this case are 3x, 5y, and 9. And we said we know these are terms because they are separated by positives and negatives. Okay, so 3x cannot be two terms. That is only one term, because between these two numbers is a multiplication. So that makes this whole thing one term. The same between 5 and y. This is 5 times y, which is 5y. So that is not two different terms. That is only qualifying as one. The only time we say we have a new term is if there's a plus or a minus between them. Okay. Now, after this nice summary of our rules, I want us to fill in this table over here. Now, big tip for your exams is first always simplify the table where you can. So we're going to see if there's anyone here that we can first simplify before we answer my question. And when I say simplify, I do not mean factorize. I'll tell you what I mean when I say that just now. Let's start off with a nice and easy one. I have x squared minus 4x plus 3. How many terms do we have here? So my first block says, tell me the number of terms. And just to recap what I just said, terms are separated by a minus or a plus. So that means, nice, Buhlale, that means I have 3 terms in this case, which are x squared, 4x, and 3. Okay. The coefficient of x. The coefficient of x, nice, Buhlale. I like that you took the symbol as well. Do not just say the coefficient of x is 4. Okay. If 4 goes with the symbol in front of it, and in this case, it is a negative, which means my coefficient of x is negative 4. And the biggest mistake we make in tests, when I ask for the coefficient of x, I am asking for the coefficient of x alone, not the coefficient of x squared or x cubed or xy. I want the coefficient of x as it stands on its own. So that is negative 4, okay? What is my constant value for this expression? Nice, Buhlali. It is a positive 3. And Bongo Musa has joined the answering train, which I love it. It is positive 3. That is the only number that we know for sure will stay a positive 3 because there is no variable next to it. So no matter what x is in this expression, it will not affect the value of this term because it will remain 3. That's what constant means. Now, what are my variables in this expression? Just x. Thank you, Bukhali. Okay. When I say variables, I am saying nothing about exponents. Okay, so regardless of the fact that this is x squared and this is just x, I only have one variable, right? If I said to you, x is equal to 2, you will substitute 2 for x squared and for negative 4x because it's the same variable. Nice, we're off to a good start. Let's look at the next one. 3x minus 3x cubed plus 4 plus 3xy. Is there anything we can simplify in this? Let's start with that. Is there anything we can simplify here? If you look at it the way it is, no. No, there isn't. Thank you, Buhlali. So let us get answering with this one. How many terms do I have here? I have 4 because they are my divisions. I have 3 divisions, which means my terms are 3x, 3x cubed, 4, 3xy. Nice, Bongomus, I see you too. So there are 4 terms in this case. Now, what is my coefficient of xy? xy. Nice, Bongomusa. Okay, that is 3. What is my constant in this case? The one that has no variable next to it? Yes, Bukhali, that would be the 4. And Linomta is back, well, has joined the answering train, which I love it. And let's see, how many different types of variables do I have here? What are my variables here? What are my variables here? Nice, Bukhali. X and Y. So my variables are X and Y. Regardless of the fact that this is an x cubed and just the x and an xy, my 2 variables in this case are x and y. Great. Let's look for the next one. Okay, I have an x squared y minus 4x times 3 plus 9 minus 7y plus 2x. Is there anything we can simplify in this case? What can be simplified? Bukhali says yes. So what is it that we can simplify for this case? Let's hear. What can we simplify for this case? Okay, so negative 4x, I'm guessing you were meant to say, and 2x. Does negative 4x go alone there? Is negative 4x on its own? My question is, am I allowed to say negative 4x plus 2x as it stands? No. What am I first supposed to do with that negative 4x? Remember, BODMAS, it doesn't go out the window. So we are first supposed to multiply by 3. So we cannot first add before we have multiplied. So let us do so. So I'm going to write this on the side. First, I'm going to just simplify this here. What is negative 4x times 3? Oh, my bracket was lousy. Negative 4x times 3. Let's hear, guys. Negative 12x. And now, do you guys see we have like terms over here between negative 12x and the positive 2x? So let us simplify that and write down my final answer. So x squared y, we can't exactly simplify. I'm just going to rewrite it the way it is. It's just x squared y. What is minus 12x plus 2x? Negative 12x plus 2x. It's not just negative 10, it's negative 10x. Okay. And then we have a plus 9, which we can't exactly do anything about. So I'm just going to rewrite it as plus 9 and minus 7y. Have we fully simplified this one? Is it now fully simplified? Yes, it is. Now we can go to answer our questions. Do you guys see what I mean when I say you must first try and simplify it? I know you guys are very tempted to answer it as it stands here, but you will lose marks if you don't first simplify it. So let's check. X squared y minus 10x plus 9 minus 7y. How many terms do we have over there? Once again, we have 3 separations, which means we have 1, 2, 3, 4 terms. Great. What is the coefficient of x? Nice. The term with x is over here. And the number in front of it is not just 10, it is negative 10. What is my constant for this one? Nice. Neo, welcome. My constant is 9, and my variables in this case, again, we have a x and a y. Nice, guys. Beautiful. Great. Let's look at my last one. M squared minus 16m. Can we do anything to simplify this? No, we cannot. Do not be tempted to factorize because that would be not simplifying it. You're doing the opposite of simplifying it. Okay. So then since we have checked and we cannot do anything about it, what are my number of terms? What is my number of terms, rather? I have 2 terms. I only have 1 separation, which means I have 2 terms, okay? And it's over here. It's a minus, which means I have 2 terms. What is my coefficient of m squared? There's nothing there, which means there is a nice. There is a 1. Okay, it cannot be 0, otherwise that term wouldn't exist. So it is 1. What is my constant in this case? There is no constant, which means the constant is what? Not 1, but 0. There we go. So remember, if it doesn't exist and you cannot see it over here, then it's a 0, which is why it's not there in the first place. Okay, and then my variables, finally, what's my variables? Just m. Don't be tempted to say m and m squared. It's just m. It's the same variable. Okay, I think that was a great warm-up for our brains, and we can now move on and revise the other stuff we have done that has to do with algebraic expressions. I'm going to leave this here for a few seconds while you guys take a screenshot. Maybe I should zoom out so you can see the other side as well. There we go. And then let you guys take a screenshot while I fix the way I'm sitting here. Okay. Now let's speak about factorizing or factorization. Okay, so these are the 3 types of factorizations that we have done. I know there's a 4th one, which is grouping, but we never really went through that, right? So if you look here, the 3 types of factorizing that we went through. The first one was the highest common factor, which could also be a common bracket. So I want to write here in brackets so that we don't forget that common factor includes common brackets. Okay. Now, the biggest tip I'm going to give you guys, this is, well, has to be, should be the first thing you look out for. This is if you see a sum and they say factorize, you must first check, before you check the others, whether you can take out a common factor. So that is a very helpful tip because as you've seen, there's been questions where we had a trinomial which was simplified by the fact that we could take out a common factor. So please make it a habit that this is the first thing you look out for, okay? Great. Now, common factor, you remember you just look for factors in both numbers that you can take out. What do they have in common? Which number goes in between 2 and 4? And we have established that that would be a 2. You factor it out and then you divide each of the terms with that number. So it didn't just vanish. This was 2x squared divided by 2. They canceled out and that's why I'm left with x squared. Make sense? Same with the second one. This was a 4. I factored it out and then I say 4 divided by the 2 and that's how I ended up with 2. So you don't just take it out and it vanishes. You divide all your terms by that factor. The second one we've spoken about is the difference of two squares, which pretty much explains itself. Difference means, which operation am I talking about if I say difference? If I say the difference of two numbers, what am I talking about? What am I explaining, Bongo Musa? The highest common factor. Let me show you what I meant. So if I have 3x squared plus 9x, okay. Now let's check, what do both of these terms have? Let's start with numbers. What number can go into both 9 and 3? That would be a 3. Thank you, Butali. So I'm going to take the 3 out. And then we look at our variables. I have an x squared and I have an x. What do they both have? What do they both have? Remember, x squared is 2x's, and this one is 1x. So they both have at least 1x. Do you see that? So I can take out 1x. All right. Now, this is what I was talking about when I spoke about what's left in the bracket. You will say, well, then my initial term divided by what I have taken out, and the same with the second term. Okay, so you write your common factor outside, and now let's look what happens when you divide. 3 divided by 3, what happens to those two? 3 divided by 3, they're gone. It's just 1, right? Yes, thank you. And now I have 2 x's, x squared, and I'm dividing by 1x. So what is left for my first term over here? If I had x times x divided by 1x, that means one of these x's will cancel out with the one I am dividing by. So what's left here is just x. Plus, again, we start with the numbers. What is 9 divided by 3? 9 divided by 3. 3 goes into itself once and will go into 9 3 times. All right. And then my variables. What happens with my variables? I only have 1x at the top and at the bottom, in the numerator and in the denominator. I only have 1x. So what will happen with the x's? They're gone. Okay, x divided by x, it's gone. So then what's left here for my second term? Just a 3. So do you see what I meant, Bongo Musa? You take out your common factor, or the factor that you've determined is common between both of them, and then you divide them to see what's left over. All right, wonderful. Now going back to difference of two squares, we said difference means what again? Which operation am I talking about if I say difference? Is it times? Is it plus? What is it? Difference means, Buhlale says multiplication. What does everyone else say? Difference is subtraction, guys. It's subtraction. Remember, sum means what? Let's have a quick summary. What does the sum of something mean? Which operation is sum? This is plus, okay? Difference is minus, okay? Product, what is product? Let's hear, what is product? We need to learn this for algebraic expressions, guys. Thank you. Product is multiply and quotient is divide. So if I'm speaking about the difference of two squares, firstly, we need to have a difference of something and something. So it has to be a number or a variable minus another number or variable. Okay. So difference of two, only two of them, squares, perfect squares. X squared is a perfect square. And then we have a 9. In this case, we said we open two brackets, which we have done over here. You open your two brackets. My first factor in both brackets is the square root of the first one. So the square root of x squared is x. So that's where those x's come from. Okay. And then the square root of 9 is 3's. And then you have two different symbols inside my bracket. We have a positive and we have a negative. Make sense? Okay. And then the last one we did was trinomials. Trinomials. Tri, the prefix tri means what? What does the prefix tri mean? Let's hear, guys. What does the prefix tri mean? It means 3. Thank you, Buhlale. So in a trinomial, if you're factorizing a trinomial, first things first is you have to have 3 terms. Okay? We see there's 2 divisions there, a plus and 3 terms, and then we're done. All right. And now let's look. Not only do you need to have 3 terms, you need to have an x squared. You cannot just have an x there and a y or something. There has to be an x squared, x, and a constant. Once again, in this case, we open our two brackets, which we have done here. All right. And then we say, what are my factors of x squared? X squared. They're x and x. Done. Now we need to decide the symbols. And remember, we said the first symbol, if it's a positive, you just write your positive in the first bracket. Are you with me? Then I said, a positive, is it a keep or a change? Let's remind ourselves. Is a positive keep or change? A positive will say keep, and that means my negative will be change. Okay, now in this case, we have a positive, which means we are keeping the second symbol. When I say keep or change, I am talking about the second symbol over here, guys, not the first one, the second one. So in this case, we have a keep positive, so they're both going to be positive. Then you look at your factors of my constant. In this case, it was 1 and 6, as well as 2 and 3. That add up to my middle term. So whatever you do, they must add up to 5x. And here we have positive 3 plus 2. Do they add up to 5? A positive 3 plus 2. Will that add up to 5? Yes, so those are my two brackets. All right. Now let's get going and checking our factorization skills. Let's just do these 4 questions. Number A, well, A. Which factorization method am I using for A? Out of these 3 that we have spoken about here, does A have a common factor? I said you always check with the common factor. Nice, Butlale, is this difference of 2 squares. And we know that because we have a minus in between and we have 2 squares, m squared and 9. So we open our 2 brackets. All right, what is my first factor here for both brackets? Don't always put x, check the question, be careful. My first factors are nice, Puhlali, M and M. Great. What are my two symbols in the brackets? One is going to be a positive and the other a negative. And then my last factors, according to this number that's over here, what is the square root of 9? We have 3 and 3, and we're done. A m plus 3 and an m minus 3. Great. Let's move on to B. Okay, 2n squared m plus 3m. First thing I said, you must check common factor. Do we have a common factor here? Do we have a common factor? Otlale says no. Please look carefully, guys. Lenomta also says no. So between the numbers and the variables, you guys are telling me there's no common factor. Be careful. Do you guys see we have an m over here and an m over here? So you must take out your m. What will be left on my first term if I remove m? This one. In my first term, what will be left? Nice, 2n squared plus what's left for my second term? A 3. Just a 3. Okay, let's look at C. This time, A, we have 3 terms. That's already a sign of something. Okay, then we have a variable squared and the variable alone and a constant. So what method are we going to use over here? What method are we going to use? This is a trinomial. I already checked that we don't have a common factor because there is no coefficient in front of my y. Do you see there's nothing there? So it's not possible for there to be a common factor. So let's get going. We're opening my two brackets. What is the first term for my two brackets? According to this guy over here, y squared. My two factors for y squared. That is y, nice. Oh, and y, great. What is my first symbol according to this one that is in my trinomial over here? My first symbol in the bracket is a negative. Thank you. And does that mean I'm going to keep or I'm going to change my second symbol? Change. So then my symbol for the second bracket will be a what? If it means I must change, I'm changing the second one. Be careful. I am changing the positive. So if I'm changing the positive, then it's going to be a negative. Okay. Nicely, Nomta. All right, I know you're not the only one who makes that mistake. Remember, this one tells us if we keep or change, but this one, the second one is where we look. Do we keep or change the second one, which is a positive, and we changed it to a negative? Great. Now, let's talk about factors of 8. What are my factors of 8, people? I'm going to write them here quickly. My factors of 8. Great. I have 2 and 4. And I also have 1 and 8. Now, we want factors that are going to add up to negative 6y. All right. So which of those factors are going to add up to 6? Thank you, guys, because 1 and 8 will never give us 6, no matter what we do with it, right? And then does it matter where I place them? In this case, doesn't matter where I place them? No, because we have the same symbol in both brackets. They're both negative. So I put a 2 here and a 4 here. And of course, we have to check. What do we have here? We have minus 2. Well, negative 2 minus 4. What's negative 2 minus 4? negative 6. And is that what we're looking for? Yes, so my two factors are correct. All right, and then let's do D before we have a little bit of a check-in. D says 3x squared minus 4xy plus 20xz. First thing, is there a common factor? Do we have a common factor? Yes, we do. What's my common factor for these three? Nice, 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 Linomta. We have x there, x over here, and x over there. So I'm going to take out my x. What is left on my first term? I had two x's. I only took out one. So what is left for my first term? 3x. Nice, guys. Second term was negative 4xy. I've taken out my x. So what's left? Negative 4y. Beautiful. And my last term, I have 20xz. I've taken out an x. So what's left? Nice. Plus 20z. Great, guys. Great, great, great. I'm going to do this so you can screenshot. And while you do that, can I please have a thumbs up, thumbs down? Please respond, guys. There's very few of you, so I'd like to know if you are getting this or not. Let's have a thumbs up, thumbs down. Nice. There we go. Great, guys. Wonderful. Okay. Cool. So, the opposite of factorizing is expanding. Oh, I like the reactions I'm getting. The opposite of factorization is expansion. That means if you look here, we have an expression that has been put into two factors. Now, if I'm going to expand it, then that means I'm going to take this factor and multiply it in. That's what expansion means, right? And what is the name we give to multiplying a monomial to a binomial? There's a special word I like to use for it. And what is that word again? Nice, Butlale. So this one, another word we call it distribution. You are distributing. You're multiplying whatever is outside with everything inside. Great, right? And then what is my special word when you have two binomials? So I have an x plus 4 and an x minus 7, and I am multiplying these two together. What is that special term that we gave to this one? What is it called, guys? Let me give you guys a clue. There, there, there. Nice. No, it's foiling. It is FOIL. All right. Then let's go through other important concepts that we have already spoken about. Of course, we spoke about adding like terms. And just to reiterate or to remind each other and ourselves, like terms have the same what and what. I want to see who remembers exactly. Like terms are terms with the same. When do we know we have like terms? Great. The first one is say variables and nice, no, and exponents. Okay, great example is x and x squared. X and x are the same variable, but my exponents are not the same, so these are not like terms. That's why you have to say they have the same variable and the same exponent. All right. Then we spoke about substitution, which is this, just plugging in a number when you've been given it. And of course, a monomial times by any number of terms. For instance, if I have 2x and a bracket that says 3y plus 2xy minus 4 plus 10z, this is just distribution still, right? You take whatever is outside and you go and multiply it by everyone inside the bracket. Now, there was a summary of everything that we have done. So let's do this one concept, and then we're going to have a little bit of a brain break. Okay. So now I have one expression here. Okay, here's our expression that we're working with. X squared times x minus 3 and negative 4 times x minus 3. And we have two separate or different instructions. I wanted to do this so that you guys can see what the difference is between these two instructions, because in a test, of course, my line is going to be yellow. In a test, it is important that you know what they are asking of you so that you do not do the wrong thing. So that's why we're using the same expression to do two different instructions. The first one says expand and simplify. Second one says factorize. Those are two different separate instructions, okay? So let's see what the difference is here. Let's see what the difference is here. When it says expand and simplify, what does that mean? It means we are not going to be using any of the factorization methods. Therefore, this is what we're going to use. Distribution, FOIL, adding like terms, all of that. That is what expansion means. So let's get going, okay? So this says x squared times x minus 3 minus 4 times x minus 3. Great. So what is happening over here? That means we're going to do what? If you look at x squared times x minus 3, how are we going to expand that? My magic word that we just spoke about just now. We're going to distribute. So I'm going to take x squared and multiply it by both my terms. And of course, I'm going to take the negative 4 and multiply it by both my terms. So let's get going. What is x squared times x? X squared times x. That is x cubed indeed. Okay, x squared times negative 3. That's minus 3x squared. Nice. We're done with the first brackets, okay? Let's move on to the next one. Now we have a negative 4 times x. Don't forget this negative. Don't leave this negative out. So then my answer will be negative 4x. And now I have a negative times a negative, 4 times 3. Negative 4 times negative 3. What is that going to give us? That is plus 12. Is there anything else we can do with this? Anything else we can do with it? No. Do not be tempted to factorize it, because that is not what the instruction was. I've seen you guys many times go backwards and end up back at your question. So if you're doing something and you end up back at the question, you did something wrong, ne? We do not want you to end up back at the question. So don't factorize it. You are done. Okay. Let's look at the second instruction, which said factorize. And once again, x squared times x minus 3. And then minus 4 times x minus 3. Now, what is the first thing that I said we look out for when we are factorizing? What is the first thing I said we look out for when we are factorizing? We need to get into the habit of doing that, guys. I said you look for a common factor. Do these two have a common factor? Yes, says Buhlali. What is the common factor? That's interesting. So just x on its own, it's inside a bracket. So that's a problem. Can I just factor out x? Remember, I said common factors include common brackets. Nice, Neil. I have a x minus 3 there and a x minus 3. So I can actually take out the whole bracket. So I'm going to write it here, x minus 3. Now, if I take out x minus 3, what's left for my first term? This whole thing is my first term. What is left over there? If I take out the whole bracket, x minus 3, nice, it's x squared. And for my second term, which I'm highlighting green, what's going to be left after I take out the common bracket? Minus 4. Great. Are we done factorizing? Are we done factorizing? Look carefully. Look at your brackets that are left. Can we do anything about x minus 3? No, we can't. Can we do anything about x squared minus 4? Look carefully. What are my different ways of factorizing, guys? I have a difference, and I have 2 squares. So, first bracket, I'm just going to rewrite it, x minus 3. Now, let's factorize my difference of 2 squares. What are my first factors for x squared? My first 2 factors for x squared. Nice. X and x. My 2 symbols in the brackets. My 2 symbols in the bracket. Plus and minus. And my factors for 4. My factors for 4, 2, and 2. That's why your question says factorize fully. That means if you didn't see this last step, you would have lost a mark or 2. Okay, do we see that the solutions for these two are vastly different? We use the same expression, but because of what my instruction was, I end up with 2 separate solutions. So it's important to know your vocabulary. If they say factorize, you do one of these. Okay? They say expand, you do one of these. If they say simplify, then it's stuff like adding like terms. All right? So you must learn the difference between the two. Can I have a thumbs up, thumbs down on this question? Both sides of this question. Do you understand why they are different? That's what I mostly want to know. There we go. There we go. Buhlale, a skull is making me nervous. Oh, we have hearts and silly faces and even an octopus. Wow. Okay, let's take a quick brain break and then we're going to do one more question and then call it a day. Right. Would you rather never ever wear deodorant again or have terrible dandruff? This I have to hear. So you either never wear deodorant or you have bad dandruff. Which one would you rather have? No one wants to be the first one. Neo says dandruff. Hectic. Nobody wants to not wear deodorant. Wow, guys. Hectic. Wow, okay, guys. Everyone seems to be picking dandruff. Next one, would you rather go to school for 4 days if it's 10 hours or for 5 days, 8 hours, which is currently what we are doing? So you either keep the current schedule or you go for less days, but you have a long day at school, which means if you start at 7, you're going to end at 5. Which one would you rather have? 4 days or 5 days? That is like 5 days is fine. I don't see myself spending 10 hours at school. Linomta seems to agree. So you guys are fine with the way the school is, the system is. LM is like, nope, give me that extra day. Give me that extra day. I'm gonna have 3-day weekends. Interesting. Next one, would you rather be covered in peanut butter or ketchup? What do you think, guys? Peanut butter or ketchup? Peanut butter, please. Do you like peanut butter, Bukhali? You sound like you do. Nice. I see. You're gonna be very sticky though. And you know it gets hard after a while when it's out the bottle. So there's a lot going on there. Oh, you'll eat it before that happened. Wow, okay. Guys, the people are saying ketchup. Have you felt how it burns? It's very acidic. Can you imagine it in your eyes? Oh my gosh, I can't imagine it in my eyes. Nope. And the last one, would you rather be allergic to chocolate or allergic to bread? Bread. Guys, do you never have sandwiches? That means you can't have what? Let's list the things you won't be able to have. Sandwiches, just based off the ingredients of bread. You won't be able to have sandwiches. You won't be able to have burgers. You won't be able to have pizza. Like anything that's bread, like you won't be able to have wraps. Oh. All for chocolate, guys. I'd rather be allergic to chocolate. I don't have a sweet tooth. I don't mind. I'll be allergic. I don't eat it anyway. You eat noodles forever. Oh my goodness. Ah, you know that. Ah, wow. It's like it's fine. We'll eat noodles forever. You can't. Yo. Okay, guys. How about we factorize one more? And I am choosing lucky number 3 because it looks very interesting. All right, methods of factorization. First thing I said is that you must what? Look for what, guys? What did I say? When you're factorizing, what is the first thing we look for? We look for a common factor. Do we have a common factor in number 3? I know there's a lot going on there, but is there a common factor? What do you guys think? Look carefully at number 3. Do you guys see a common factor? Or a common bracket? That's a big clue. Anyone? Look here, guys. X plus 2, x plus 2, x plus 2. That means x plus 2 is my common bracket. Great. So then let me write this down. If I take out x plus 2, what is left for my first term? You guys need to have more confidence and answer when I ask, not after. I know you guys know the answers. What's left for my first one? X squared. That's true. For my second term, what's left for my second term? Negative x. Nice. And for my last term, over here, minus 6. Have we factorized this fully? Remember, confidence in your answers, even if you're not sure. No, we haven't, right? We still have a trinomial. Do you guys see it? We still have a trinomial. So let's get working with the trinomial. I'm going to leave my x plus 2 on the side because we're done with it, right? There's nothing else we can do with that x plus 2. I open my 2 brackets and let's get going. First factors that give us x squared. X and x. Great. What is my first symbol according to the symbol in my bracket? My first symbol will be a negative. Nice. Now, will this negative say I must keep or I must change the second one? Am I keeping or changing the second one? I am changing it to a plus. Great. Now let's go through my factors of 6. I have 1 times 6 and 2 times 3. I want a factor that's going to give me negative x. If there's nothing in front of my x, what is there? There's nothing in front of my x, then which number is there? A 1. So we want factors that are going to give us negative 1, not just 1. If you look carefully here, this is a negative. So we want factors that are going to give us negative 1. Great. Okay, which 2 factors are going to give us negative 1? 2 and 3, but we need to be careful where we place them. Okay, where do we place them? Because I want a negative 1, not a positive 1. So is my 3 positive or negative? Nice, Butlali. Negative 3